Okay, so we're going to be applying our normal distribution formulas. Now, I want us to play between the z-scored and the x value. I know our formula. Let me remind you guys of our formula. Our c-scored is my x minus mu divided by sigma. Right, mu and sigma are usually given. Mu, again, is our average, our mean, however you guys want to call it. And sigma is the standard deviation. So mu and sigma are usually given. But sometimes we have to find the z-score. Sometimes we have to find x. Now, I mentioned a table, right? I gave you guys a table of the z-scores. So in order for us to be able to use that table, we have to have our z-score, our z value. Sometimes I give you the C value and then I just ask you for a probability. Sometimes I give you the X value and I ask you for a probability. So I want us to be playing between the Z and the X. So we have to be paying attention. What do I give you? Now here, for the first part, it says find the area under the standard normal probability distribution between the following pairs of Z-scores. Okay, so I'm going to give you the C value, the Z-score. So we can already use our table. Now, one thing of our table, right? When we read the table, it gives us the probability from the center when C is equal to 0. So it gives us a probability of that. So now looking at here, it says find the area in between Z is equal to 0 and Z is equal to 0.27. When I'm looking at this as a graph, Z is equal to 0, basically that's the mean. When Z is equal to 0.27, it goes to the right. So my Z is equal to 0, 0 is equal to 0.27. I'm looking at this area. Okay, now for me to find this, I'm gonna use the table that I gave you. In reality, I'm just gonna look for Z is equal to 0.27 because that table is gonna give me the probability, right? The area under the shape from the mean. And remember here at the 0, this is our mean, our mu. So in reality, I'm just going to use a table. I'm going to look at the 0.27. Gives me a probability. It gives me 4 decimal places. So let's take a look. Remember, the value I'm looking for is 0.27. This is a little reminder. This table on the left gives me up to my first decimal place. So in reality, I'm going to look up until 0.2. This table on the right, on the top, gives me my second decimal place. Remember, the z-score that I'm looking for is 0.27. So let's take a look. 0.2 is right here. Again, I'm looking up to my first decimal place. My second decimal place is a 7, so it's right here. Reading this table, 0.27, my probability is 0.1064. Okay. Let me come back to my work here. So I know this area is 0.01064. Good, that's it. It was that simple. I just want us to be able to go back to the table and read given the z-score. Remember that area is the distance from the mean, basically when Z is equal to 0. Now, I may ask you, round it to 4 decimal places, that's it, 0.1064. I may ask you, in this case, actually I will ask you to give me the answer rounded to 3 decimal places. So make sure you guys pay attention to the instructions. Because I'm asking to 3 decimal places on the homework, for this case, I'm going to expect 0.106. Now, some of you might be, well, can I write just 0.106 or do I have to write the 0 before the decimal? Either way will be okay. They're basically the same number, right? Either way will be okay. Let's take a look at the second example. Want to know the area in between Z is equal to negative 1.54 and Z is equal to 0. Again, z is equal to 0. That's basically my mean, the mu. So looking at our graph, will look something like this. Z is equal to 0. It's right there. Z is equal to negative 1.54. So that means I go to the left, negative 1.54. And I'm looking at this area. Now, on our table, remember it only gives us everything to the right of mu. So on my table, let me do this in blue so we see the difference. I'm going to look at 1.54 because that will give me this area. The area in red is equal to the area in blue. So it doesn't matter which one I get, it's the same thing. All right, so let me go 1.54. That's what I'm looking for. Let me even write it up here, 1.54. So when I look at up to my first decimal place is 1.5. That is right here, 1.5. My second decimal place is a 4. So here's my 4. If I look at my intersection here is 0.4382. Okay. So the blue area is 0.4382. So the area in blue is 0.4382. What's the area in red? It's the same. Now let me answer to 3 decimal places. I'm gonna call this 0.438. So every time I give you the C score, just go straight to the table. Let's take a look at here. Find the following probability for the standard normal random variable z. What's the probability that z is less than or equal to 1? Okay, so let's see. Let's take a look. So that's my bell shape. Here's my mu in the center. Z is equal to positive 1. So that means I move 1 standard deviation to the right. I know if I go to my chart, it's going to give me this value. Let's take a look. Z is equal to 1. So let me write that down. 1, I can see that as 1.00, right? So when I look at up to my first decimal place, it's right here. I look at my second decimal place, it's right here. So that area is 0.3413. So 0. What did I say that was? Let me see. I said 3413. Okay. Okay, so, but I'm not just interested on that. I'm not just interested from 1 to mu. I'm actually interested on all of this. I know that section in red is 0.3413. Let me write in black. I wish I knew this. Okay. Remember, it is to the left of the center. Isn't that half of our probability? So I'm going to say that is 0.5. So my black section is 0.5. The red section is 0.3413. I'm interested in the blue section, which is all of this combined. So just add them up. That will give me 0.8413. Now, if I ask you round it to 3 decimal places, right? I do take a look at the 4th decimal place. It's too small. Too small is 4 or less. So I'm just going to ignore this. It's going to be 0.841. Now, looking at our next question, let me do this. What's the probability that z is less than 1? So here's my mu. Here's my 1. Pretty sure if I go check the chart, gonna tell me this section right here is 0.3413. And I know this other section right here is 0.5. Now in reality, it looks like the question that we just did. The previous question had less than or equal to, and this section has less than, not the equal to. Well, guess what? My answer is the same thing. It doesn't matter if I get the less than or equal to sign or just the less than. My answer in here will be 0.841. That inequality does not, which inequality you get, less than or less than or equal to, doesn't matter. You get the same probability, 0.841. Now, this last one here, here's my mu, here's my 1. This black section, according to our chart, is 0.3413. This older part right here, since it's half of my probability, 0.5, I know all of this combined is 0.841. Now here, I'm asking you, probability that z is more than 1. Let's pay attention. Let's do this in red. I'm actually interested in this part. Couple things I could do. One of them, let me call this x. I learned in algebra that when I don't know the value of something, I call it a variable. So let me call that x. And I'm just gonna say 0.841 plus x. So I combined those, and that gives me the area under the whole graph. The whole probability is in that 1. Okay, so solve for x. Let me move this as a minus 0.841. So I'm going to get that x is equal to 0.159. Cool, not too bad. So we know how to use inequalities. Now there is one thing that might give me a problem. Let me come up with an extra question here. What's the probability that z is equal to 1? Okay, so I was working with inequalities. Every time I'm asking for a probability of a z is equal to exactly a number, that this line, it's so thin, so thin, because it's a line, that it doesn't have any width, right? So I want to say when we use the equal sign, the probability of something equal a line is going to be 0. So the equal sign will be a problem, but inequalities are all fair game. Okay, now we know how to use our z value. What if I give you the x value? Suppose that x is a normally distributed random variable with our mu is equal to 33 and our sigma is equal to 8. Find the value of x, zeros of the random variable x. Okay, so what I want the probability to be to the left of this x0 to be 0.25. Okay, so let me take a look at a graph. I know this whole half right here is 0.5. And I want the probability to be 0.025. Ooh, so that's going to be somewhere to the left. Let me use black. I don't know exactly where it is, so I'm going to call this x0. I'm going to put it right there. But I want this part, this area, to be 0.025. Okay. So that means that I want this area, I'm going to point out this other area to be 0.475. Huh. Where did I get that number from? 0.475. Well, I know those two areas combined is 0.5, right? So I just went 0.5 minus 0.025, and that's how I got 0.475. I'm gonna use my table. I want to see which C-score. C-score gives me the probability of 0.475. So let's take a look at our table here. Erase this. Remember, what I'm looking for is 0.475. When I look at this as 4 decimal places, 0.4750. So let me take a look at these. Where is that probability? It has to be somewhere here. It's right there. You guys see 0.4750. What's my C-score? Well, here on the left, I see 1.9. Here on the top, I see 0.06. So that means my C-score is 1.96. Okay. Let me come back here. So remember, I need my C-score to be 1.96. That's my C-score. But I didn't ask you for Z, right? I asked you for X. So you're like, okay, I remembered the formula for the C-score. C-score is X minus mu divided by sigma. I know my C-score in this case has to be a negative 1.96, right? Because we went to the left. I don't know what my X is, but I know my mu is 33 and my sigma is 8. So doesn't this look like a simple algebra question? Okay, let me get rid of fractions. Let me multiply both sides by 8. And the reason why, because that way this 8 cancel out. Now negative 1.96 times 8 is negative 15.68. And that is X minus 33. Now to get the X by itself, let me move this minus 33 as a positive 33 here. So I have 33 minus 15.68. According to my calculator, that is 17.32. That's X. Or how the question was calling it, X of 0. So there. My X value is 17.32. Okay, not bad. Let's take a look here. The random variable X has a normal distribution with the standard deviation of 25. Okay, so my standard deviation is 25. It is known that probability X exceeds 150 is 0.9. Okay, this is my probability. Find the mean. I don't know the average. Find the mean of the probability distribution. Okay, so I have some probability, 0.9. Let me use my table here. When I look at the probabilities, I'm like, it doesn't go up to 0.9. The highest it goes is 0.49997. That reason is because that's only considering from the centered. The 0.5 So in reality, since I want it all to be 0.9, I'm just gonna look for 0.4 because everything to the left, the first 0.5 is not included. So okay, so let me find what's 0.4. So 0.400, it should be in between here. Okay, so it's more than 0.3997, but it's less than 0.4015. I want it to be higher than zero point 0.4, so I'm gonna use this one. Okay, so here to the left, I see a 1.2. Here to the top, I see 0.09. So that means my C-scored is 1.29. Okay, so let's go back here. I remember my formula, x minus mu divided by sigma, it's equal to my C-score. So I don't know what the x is, but I'm just gonna go x minus 150 divided by 25, because my standard deviation is 25, and this has to equal to 1.29. That's my C-score. All right, let me get rid of fractions. Let me multiply both sides by 25. That way these cancel out. So I have x minus 150. Now 1.29 times 25 is 32.25. To get the x by itself, let me go the minus 150. Let me move it over as a plus 150. So I get my x, or x of 0, how sometimes the book likes to call it. 32.25 plus 150. Use a calculator if you need to. It gives me 182.25. So I want us to use the C-scored. You guys see here that I use the C-scored. I want us to use our X value.